We started at 0.19 in this step, and now we're going to add 6.2 times 10 to the negative 8 molarity of hydrogen ions to it. Do you see why we don't need the second step now? You're laughing. What are you laughing at? Oh, okay. I didn't know if I had done something wrong. This is just confirmation that we don't need to do any more steps after the first step to find the pH. So we can find the pH just from that. And we got 0.9 for the 0.19 for the hydrogen concentration in the first step. Second step, the hydrogen concentration is still 0.19. We didn't need to do it. Yes? Okay. Now, at this point, we found the concentration of everything so far. The only thing we won't know the concentration of is the PO4. We would do another step. Same way, you take this concentration. That's the X term, the HPO4. That's the initial concentration in the next step to find the PO4 concentration. So as you see, the PO4 is very, very tiny, its amount. On the next slide, this will be the last one for today, you may run into a problem in which it'll say, here's the concentration initially of the polyprotic acid. What's the concentration of our stripped down, no hydrogen negative ion? Now, as we started in the previous slide, you could do the 3 ice table setups and just carry your new concentration of the dissociating ion down. That would work. That would be fine. But there is a shortcut to this. I want to show you what it is. Here are the 3 acid dissociation constants. Don't write this down. You already wrote it down. Our 3 Ks for the 3 steps in the phosphoric acid. So in this case, this is not the same problem because last time we were starting with 5 molar. This one's only 1 molar. What would be the phosphate concentration? Rather than doing 3 ice tables, a quick shortcut would be this. How about we add all 3 of these equations together? You remember doing that, adding equations together? I think that this thing would cancel out that thing, and then that would cancel out that, and we would be left with just H3PO4 on the left, and then 3 hydrogen ions and the phosphate. So when I do that, add my equations together, what happens to the Ks? What do we do with the Ks? Do we add them together too? Yeah, they get multiplied. Delta H's get added together, but K's get multiplied together. So here it is. It's a dumb K value. It's like how tiny that is. So the K value is 2.2 times 10 to the negative 22nd. So now, the question is, what is the phosphate concentrator? Wow, that has taken away 3 ice tables down to 1. We have a K value. There's one little thing that's a hang-up on this. I want to show you what it is. Our initial concentration of H3PO4 is given to us, 1 molar. So initially, I'm going to have that up here. The one thing that we have to be careful of is this. I'm just going to pause. The folks are still writing things down. Now, what makes this different from solving other problems that we've done in this chapter, and like I said on the previous one, we're used to having 0 of the products. But be careful with polyprotics. when you add these equations together, by the time you get to making PO4 after the first two steps have happened, isn't there going to be an initial concentration of hydrogen? On the way to getting to PO4, we've released enough hydrogen that we can't neglect it. Don't say that the hydrogen initially is 0. How do we know what the hydrogen is, though? Well, remember, it's the first step that dominates how much hydrogen and what the pH of the solution is going to be. So let's just do this first step quickly. Notice we're not going to make up an ice table. I think you've made enough ice tables now that we can just look at this first step. Knowing that the initial concentration is 1 molarity, we could say, okay, here's the K. Isn't it going to be x squared over 1 minus x? We can make that jump, can't we? We know that this is going to go down by x. Those go up by x from 0. So at equilibrium, it's going to be x squared over 1 minus x. Is that too far of a jump? Okay. So we have to do the ice table. This is going to be a really small one. That's 0 and that's 0. That goes down by x. Those go up by x. So at equilibrium, you got 1 minus x here, x, and x. So that's how I came up with that. When you solve for x with just Ka1, that gives you the hydrogen concentration. And remember, that does not change as we go from step to step because it's only the first step there that produces enough for us to be interested in. The other was produce a tiny amount of the negligible. That x value is, well, we're neglecting this term. It's just the square root of this number right here, 0.083. So, when we make up our ice table for solving for this term, I have an initial concentration of phosphoric acid was 1. When the reaction is making PO4, we have made, from the first step, 0.083 molarity of hydrogen on it. That can't be neglected. You got to include it. This only happens, you're only going to have an initial concentration of a reactant, not of a product, for the polyprotics. Every other acid dissociation in this chapter had 0 for the products every time. The rest of it now is just making our ice table. Now, I've had questions both hours so far today. Do I need to multiply that concentration by 3? No. No. That 3 is there to tell us what ratio those react in. Like when one of these breaks up, you get